My name is Maxim. Maki, and I'm going to talk about toki pona and the way I process it with Perl. And this is going to be an entertaining, amusing talk and interactive as much as possible. So please be engaged, be involved.
First question, I have no idea what toki pona is.
And I will explain it and even demonstrate it right in the next slides. So, toki pona is something I'm passionate about myself. That's a constructed language, which means it's artificial, and I've been how do I say this? Like having fun with it for many years, like revisiting, not like constantly, but revisiting it maybe like every half a year or so. And that's why I would like to share my passion about this language with you and hope to inspire you in some ways. So let's set the question policy that shall we have any little questions, because we have quite a few material. It's pretty tense. Just shout out and we will see. Okay. So apparently we have no internet connection here, as I figured. We will have, well, I guess we are supposed to have some live demo. And for that you could install these modules to be ready and run on your laptops. But if you are lucky to have a mirror of cPanel on your laptop, you still can install these modules. And if you have any kind of internet connection, you can download the files. It's on my GitHub account, and this link is also in the talk description on the LPW site. So you'll be able to find all the material presented here and play with it later. So, a few words about myself. I'm an enthusiast programmer. I've been doing programming since a kid. Started with ZX Spectrum, invented in this country, as far as I know. I work for Booking.com. We do online accommodation bookings. We are based in Amsterdam, and we are very much hiring all variety of different developers, designers. If you're interested, come to me or to one of my colleagues. That's my Twitter, GitHub account, Maxim Vuets, and my email address, shall you want to contact me. The agenda of the talk, so we will cover what toki pona is, what, why, when, who invented it, its principles, features, the language itself, its alphabet, lexicon, phonetics, writing systems, a couple of them. And then I will show you a couple of real-world examples how the toki pona is used in real world, so it's not just like a hype, it's actually being used. Then we will cover MARPA. It's a Perl parser. It's a parsing library with bindings written in C, but bindings available in Perl. That's why it's popular in the Perl community. And at the end, I will try to gloss over the Markov chain algorithms and demonstrate how it can be employed to generate rubbish in toki pona. So let's begin. The first three W's, what, who, and when. Toki pona is a constructed language. You can think like Klingon or Esperanto. I'm pretty sure you've heard of this language. Toki pona is like a likeless language. It was made by a human being, by Sonia Lang, a Canadian translator and linguist, in 2001. Actually, it was made before that. It was her private project. She was her philosophical attempt to find the meaning of life, and through inventing this language. And in 2001, she decided to release it to public, and it was born on the internet. It's very minimalistic. It has a very little vocabulary, very simple grammar, and trivial phonetics. So it can be spoken and used by the variety of nations and people from all around the world. The name of the language itself, toki pona, means toki is a language, pona is good, so it's translated as a good language or a language of good. Disclaimer, one little disclaimer though. Do not take this as another international auxiliary language, like the language that you could use to bond all people together, like Esperanto or something. It's a terrible idea to do legal stuff in this language. You will see why. Not even to mention like write chemistry textbooks or something. So take that as granted. Now, the last W. A couple of like features of the language. So let me just check this one. The first of KISS principle, keep it simple, stupid. The language tries to simplify all the things. So the modern world and languages are too cluttered with all these difficult, complex words and concepts to express pretty much simple things. Toki pona tries to get rid of that and like break down everything into simple, essential, basic elements. Another thing why you may like this language is to flex your brain. Who of you have tried programming in functional languages?
Less than
For example, have you experienced them like slightly different and trying to adapt and flex your brain to think in a different way maybe? Or something I experienced myself when I tried to do TCL. Like it took me a weekend like to understand the language. It was like no idea. Like, I see. So like, you can take it as a brain teaser. It's not trivial to take the language and just use it right away. You need to kind of adapt your brain a little bit. So if you like this kind of like exercises, you may like this too. Fun and joy. I think it's pretty obvious, pretty self-descriptive, because we like learning new stuff. We are curious. It's really nice. New thing, you'll get it. And enlightenment. That's something the author was coming from. Like there is this Sapir-Whorf hypothesis, also known as the principle of linguistics, with linguistic relativity, that goes. The language basically determines the way of thinking. And if you can think in terms of a different language, you can basically develop a different world view. Like, look at the same physical objects and things from a different perspective and perceive them in a different way. So you may get some enlightenment. So, and most of these ideas, we will see how they are implemented in the language during the next couple of slides. So first of all, keeping it simple and simplifying things is the language tries to get rid of all the redundancy. For example, there is no a single word to say hungry in Toki pona. You say vile moku. And a question to the audience: how can you say I am hungry or just hungry in a different way? Simple other words. Any ideas?
Want food?
Exactly. So that's what vile moku means. Vile is to want, moku is food. So I want it, or I want food. Another one, to teach. Pana esona. Any ideas? Pana is to give, as a special word to introduce an object. And sona is knowledge. To teach is to give knowledge. Happy, pilin pona. Exactly. A girl, mele lili.
Young female?
Hmm?
Young female?
Close. Very young. Lily. Little. Exactly. A little woman. Friend, Jan Pona. That is, Pona, you know the word. Jan is a person. So that would be a good person. And if you are wondering, like, this might be not a good idea, we've been actually doing this for centuries. This is ancient Greek geology, which means earth and study of, right? Literally. So they were not saying geology, they were saying like, hey, what are you studying? I'm studying the study of earth. Right? So like, we already combined the existing words and to make up new words, and this is basically the way like the Toki pona does it as well. Moving on, simplifying it further. These are numerals that exist in Toki pona. So on the left-hand side, you can see all the four numerals that exist in toki pona. It's ala, which is 0 or nothing, 1, which is 1, 2, which is 2, and mute, which is many. These were authentic, like original numericals, and basically if you wanted to express a quantity of, say, 5, you would say 2 to 1. If you wanted to express a quantity of 27, you go mute, because you don't need to be specific. It's like too much details. It just overloads the brain. Unfortunately, in my opinion, people didn't really like that, so they came up with different ways to be more precise, and they overloaded, reused some existing words. And literally, luka, which is a hand, because it has 5 fingers, it may represent a number 5. Mute, they made to denote 20, and ale, which is everything, they made it to denote 100. I'm not really fond of this idea, to be honest. But you might see this, may experience this. And again, like to prove that it's not a completely insane idea, there is this Munduruku tribe living in the Amazon River basin. They have only 5 numbers, so it's real human beings who naturally developed, and they have in their language only the numbers to, on the words to express the quantities from 1 to 5. So if one asks how much fish did you catch, they cannot say like 7. They would say like many. It's very interesting. You can look it up and read more about that, how they actually live and survive without a need to express the exact quantities. And then they naturally developed, like they would rather like compare sets, like is my army larger than yours, like I'm going to defeat you or be defeated. So like they don't really need to count soldiers and people. That's how they get away with this. And simplifying furthermore, colors. There are only 3 colors: loye, yellow, lasso, and valo and pimea is white or light and black or dark. These are the colors from the RYB model that predates CMYK that used in modern printers. The people doing painting or arts may be familiar with this. That's basically the colors you mix on the palette to make other colors. If you need to make another color, like what would it be, green, you mix blue and yellow, like colors and words, and you get yellow lasso, which means green. Now, we are all familiar with this Perl's model, right? There is more than one way to do it. Toki pona employs a very similar one. There is more than one way to understand it. And I will demonstrate you how. So, you've seen this apple before. To say an apple in toki pona, the word for apple is kili, right? So this is kili. Now, how do you think you would call this fruit?
Yellow.
What is it? No, it's actually it's also
Not kili.
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 But it's like vegetable fruits, right? What if it comes down to say vegetables? Like what is it? It's not a tricky question.
Kili.
It's cabbage, right? And toki pona, it's also kili. So all these fruits and vegetables, mushrooms, berries, it's all the one single word kili to represent the entire class. Now, due to this, due to the small vocabulary, the language is vague and ambiguous, but it's not a limitation of law. It's actually very deliberate and absolutely fine, and you often don't need that. And I'm going to demonstrate this. So say we are having a nice dinner, we sit by a table, we have fruits and vegetables, kili, right? And we also have a bottle of wine. And I sit on this end of the table and asking someone to pass me the bottle of wine. So I would go, opana e blank, tava mi, which means pass blank towards me, or makes it a command, and I is a grammar, one of the 3 words of grammar. And to say wine, you don't need to be specific and have a dedicated individual word for wine. You may just say telo, which represents any type of liquid. Since this is the only liquid on the table, it suffices. You just say, could you please pass me the liquid? And that works. But it would be too easy, right? Let's say that we also have, there would be, right, we also have milk on the table, right? So now it's two liquids. And now it's ambiguous. Now you cannot just go with liquid. So you need to be a little bit more specific. And now you know this word. So there would be, please give me the fruit water. It's made of grapes, right? So you can definitely distinguish milk from the juicy kind of liquid. Opana etelokili tavami. But it would be too simple. Let's say we also got juice. Now we have two telokili on the table. How can you be more distinct in this case?
Color?
Color would be one way to go. Another way to go would be to describe it. Telokili musi. And musi is amusing, fun, entertaining. Right? So the liquid that makes you feel fun. But this is what comes in very interesting here is that say exactly the same situation, but it's not me asking a person on the opposite end to pass the wine, but it's actually my wife sitting by the table and seeing that I have had enough, and she should get it away from me. So she would go probably with Opana etelo nasa tavami, where nasa means crazy, mad, insane, like that, the crazy water that actually not making you fun anymore, but right? So like that's demonstrate the idea of the language that you do not want to describe the object itself, but you want to look into the essence. What is it, right? So it's just like a bottle of wine, but depending on the standpoint of view, it can be perceived different ways. Now, more about the language itself. This is the alphabet. It consists of Latin letters, 14 letters. Nothing special. But why the alphabet was stripped down is because phonetic is very permissive. So they all sound pretty much as in English. Maybe J sounds like Y in yellow, U. And because it was made so it can be spoken by different people coming from different backgrounds. The phonetic is permissive in a way that sound T may be pronounced as D, or K as G. So you could say instead of toki, say dogi, and that would mean exactly the same word. And the first syllable it's consistent. The first syllable of a word is always stressed. Now this is the entire vocabulary of the language that fits on one single slide. This is all that 120 words of toki pona. Plus this 4 in blue ink, they were deprecated, superseded by other words. So the language actually developed during the years. Some were abandoned, deprecated, some were added. So you can see that it's pretty feasible to grasp the language in a couple of weeks, since its vocabulary fits on a single slide. You can also see that they all are in lowercase, and toki pona always use lowercase except of proper names, like people names, country names, river names, stuff like that. This, because the vocabulary is very small and succinct, that makes the language really appealing to represent a word with a single symbol. And people came up with a lot of these crazy ideas how to write the language, and this is one of them. It's called sitel and pona, where each icon, each symbol represents a single word from the language. So you only need 120 symbols. And this, if you try to read this, it would be sina suno mi, li suno taso mi, con li pimeia la mi pilin pona, sina sona ala olin mi, oveka ala esuno mi. And the English translation of that would be, you should recognize it, You are my sunshine, my only sunshine. You make me happy when the skies are gray. You will never know, dear, how much I love you. Please don't take my sunshine away. Would be really nice to make another graphical alphabet made of emoji. Anyone? Any takers? Now, two real-world examples. There is a official Toki Pona forum where people hang out, ask questions, speak in Toki Pona. People make comics. I'm good. Horrible enemy, or not enemy, animal. Food is good. People make films. This one goes in a like really monster-like voice. Suno pona, pini pona, alili pona. Which means a perfect day, a perfect end, everything will be good. There is a Wikipedia, written entirely in Toki Pona. Since it's not a real, like not an officially recognized language, it doesn't read on the wikipedia.org domain, but on the Wikia. But it's pretty comprehensive. And you have these categories: young people, Kulupuyan is societies, Pali is work activities, Ma lands, continents, countries also, Mopu food, Musi entertainments, Sona knowledge, Soveli and Akisi it's two types of animals, Tenpopini time, which is like history, and Toki languages. And they have, at the moment I took the screenshot, it was back in August, they had 5-10 articles on the site. Another proof the language is sufficient. The Little Prince, entirely translated into Toki Pona. Just one example, people translate crazy stuff, like Monty Python. Someone translated the entire script. I took the Witch Village episode and made subtitles for it. And if you're curious, I can show you later. It's really fun. The Lord of the Rings, someone translated the poster. People go crazy. Translate. Sorry, NES games. Thanks. Does anyone recognize this game? Any old people in the room? I didn't really know it. But what's interesting...
I'm too old for Zelda.
But what's interesting here is this phrase, O pilin enena, which you may guess is press any button to continue, but press any key. Pilin means also to touch or feel, and nena is any kind of bump or something stick around. So you can interpret it as a press any key, or touch the nose, or feel the breast, or so it's open for interpretations. Now, that's part about the Toki Pona. It's now an excuse to actually talk about this in a Perl conference. I was like wondering for a long time how I could, since the language is very simple, small, I thought maybe I could somehow use it together with Perl, and maybe parse it, but I didn't really have a nice idea what I could do. And then I stumbled across this formal grammar someone made for the Toki Pona language. And then Ben asked me like, hey, have you tried MARPA? Because MARPA takes the BNF as a way to describe the grammar as input. And he said like, maybe you could like marry them up together. And I'm like, oh, that's a nice idea. So then I spend some time and trying to adapt that formal grammar, load it into MARPA, and make MARPA parse toki pona sentences. But before we go to that, I would like to quickly, very superficially refresh what is parsing in general. So to parse is to take the input of some characters, strings, text, and then make some sense of how to get some, find some structures. So say we have this artificial Perl looking like language with of two statements. So if we wanted to interpret it, we would probably want to have some kind of data structure memory like this. So we would have some assign operator, give it a variable name and the value you want to assign to that variable. And then when we have a function call with some arguments we would like to have. Please call the function, the function name, and in this case a single argument, right? So to parse that would be to come up with this tree. The Perl is really great at text processing. It's known for its regex power, but regexes are really nice for text pattern matching, not really for parsing. So if you wanted to parse that program, you would need to write something like this. It has nice capabilities. You would have a grammar representing the anchor, so it should always match from the point it matched last time, and then you have a variable, some white spaces, the equals, and the number we assign, or the function call, the arguments, or it can be just a blank line, etc. And then in the loop, you take the regex, you use the GK to benefit from this, so you always match from the point you ended last time, and don't just leap over some arbitrary text that just matches. And then here you would actually see what matched and try to do something. It's pretty dense, especially for complex grammars. But we could also represent it in a BNF way. Is everyone familiar with the BNF notation? No? So this is BNF. I struggle to explain it. I hope it's self-explanatory. So that's basically you say, this is a rule, some structural element, and it's defined like this. So in this case, we want to have one or more statements. And what is a statement? A statement is some variable, a sign operator, and a number, or it might be a function call and a variable. And then you explain it further. Like a variable would be a $sign, a literal, and then the regex. So there would be a alphanumeric, one or more alphanumeric characters. The assign operator is simply just a literal, one equal sign, and so on. And here you say, you define what is a white space. That's actually a proper MARPA grammar. And you have a special pseudorule saying discard everything that is a white space. So because the language is white space tolerant, agnostic. And this is very nice and easy to follow way to describe the grammar. Now, about MARPA itself. It's a parsing algorithm implemented as a C library with bindings available in Perl. It comes in a bunch of different interfaces. They develop over the time. The one that is most interesting for us is Slip, which is scanless interface that actually takes the BNF as an input. You just literally give it a blob of text representing your grammar. It parses it itself and does all the magic. The MARPA itself, why it's great, it's powerful, convenient, fast, and flexible. What distinguishes it also is it can handle ambiguous grammars. So if there is more than one way to match the rules on the given text, it will parse them all. It won't just bail out like most of the parsers would do. I am not an expert in MARPA. I actually learn it while working on the talk, so I know it very superficially. So if you have some way, if you're parsers experts, please bear with me. Now, what we are going to do is the NLP, the natural language processing guys. They use, this is one of the notations that's used to actually have some, analyze syntax of the sentences, of the languages, of the spoken languages. So to give it a phrase, John ate the cat, they break it down into this tree. That S would be the sentence that consists of a noun phrase and a verb phrase. The noun phrase in this case would be a proper name John, and the verb phrase would consist of a verb ate and a noun phrase consisting of an article there and a noun cat. It's you don't like really need to understand it like linguistics. I have if you're interested, I have a couple of convenient links in the repo that's available online about the linguistic stuff. I was a little bit exposed to that, so I got some idea. But it's a way to represent it graphically in a text format. It's more convenient to represent it in a form of S expressions. Pretty much the same tree. So this is my sentence consisting of noun phrase and a verb phrase, and so on. So this is what we're going to do. We want to parse the toki pona into the syntax tree. So we will have this as an output, right? And now when it gets complicated, because I wanted to show you all this in action for real, we will see what we can do. So I have a series of this. How can I open it? Could you see?
Right click, open with, cancel out of that. Oh, then try to execute.
That wasn't the right. I got it. Oops. So this is our starting point. Is there a way that I can increase the font size easily? Zoom in of anyhow?
What are you looking for?
Zoom in. Increase the font size.
Zoom.
So people can actually read that in the script. Or if I scroll.
There aren't many people in the room, maybe we could just all move forward.
Yeah, you can actually see it quite well, actually.
I can see it fine.
Yeah. Would it be green? Then I don't remember that. Anyway. I think that's actually better, right? It's more bold. So this is like the boilerplate we start from. We create the object of the parser and give it the BNF, which in this case is just empty string. And then we have the me moku, I eat or I'm food of toki pona, and we ask it to parse it. If you run it, it will shut down, complaining that it cannot parse it because there is no grammar, so it doesn't match. So then we take another step and enhance it and actually define a grammar. In this case, this line here. In this case, we define it just as a sequence of 3 literals, me, space, and moku. So we just wanted to match explicitly. And after that, we would get an empty output. It would be just undef in this case. It matched, but it has no semantics attached to this. So like the input conforms to the defined grammar, but we didn't ask it to do anything with this. If you move forward, now we use the special syntax of Marta. It's a pseudo rule started with a column, and then we assign an action. And this part will be applied to all the structural rules. That's why it's called default. So this is applied by default to all the rules defined in the grammar. An action is a way to say, hey, invoke this function every time this rule matches. And now we have another special convenient Marta functionality. You can just specify here a namespace and a subroutine we want to invoke. But if it's enclosed in square brackets, MARPA substitutes, evaluates that rule as a array reference with a value specified. So in this case, it would fill it with a name of the rules that matched, S in this case, and the values that matched. And now if we run this, we will actually see an array consisting of values S, me, space, and more. The next step would be to get rid of hard-coded strings and actually define some structure. So we say the sentence is a subject, white space, and predicate. And in this case, the subject might be me, just to keep it simple. It might be a bunch of words or different, more sophisticated rules. Predicate is mob, and white space is everything that is more or one or more spaces. That will evaluate to pretty much the same result. But now we are defining more structure. The next step would be, because we are not interested in spaces, we can use the special pseudo rule discard and say that everything that looks like this, it shouldn't be taken into account. And then if we run it, we will see only the essence of the sentence. S, me, and Moku, and the space, this space will be dropped. Now, next, we get rid of the default rule that we just had before and actually define our own custom rule that lives in the namespace action URL, and this is the function. We are not going to dig into this, but the what function does, it looks into the rules that matched, constructs a string, and actually does that as expression string as it parses the input down to the top. And now if you run this, we will actually have a string that looks exactly like the one on the slide, with S and the value is parsed. Now, trying to make it more interesting, we say that the sentence stays the same. It may be subject and predicate, but the predicate in this case not necessarily has to be a verb. It might be an object. So it's either of them. But because toki pona is ambiguous, and MARPA can handle ambiguity pretty well, verb may be moku, but moku might be exactly the same way be an object. So when you say me moku, it might mean I am food, but also I am it. So they are completely proper, valid sentences, and they should be parsed as either a verb or an object. Even a human being cannot tell the difference without the context, right? So the computers cannot tell it. So they will, if you try to run this, it will bail out complaining that there are more than one way to parse this and it cannot handle it. So what you need to do is to switch from this very simple high-level interface to something more sophisticated. That would be you create an R object, I think it's leader if I'm not mistaken, and then you give it the grammar, which you construct here. And then in the loop, you go over all possible values. And if you try to parse them, you will have like all possible parse trees of that sentence. So you will have the mimoku being parsed as subject verb and subject object. If you are interested, I can show you all this interactively on my laptop. Apologies for technical limitations. Now, let's see. Like going step by step, we can end up with something like this. This is actually the parser. So this is pretty much the same as you've seen before, just with some more syntax sugar at top of it. And this is the grammar that I found on the internet, made by this gentleman, Zach Tomaszewski. And I just slightly adapted it to my case. So you can see all this NLP linguistics. Sorry, it's a little bit all these linguistic terms, like noun phrases, modificators, predicates, verb phrases, etc. It's way more sophisticated than our example, but like eventually evolving to that. And it defines all these words, and these are actual strings. So now having this, again, I unfortunately cannot demonstrate it here. You can give it sentences and get this huge, enormous, scary trees parts of the sentences. Now, what I was thinking also that would be nice to. So how you can actually use it? You can use it to validate if your sentences are properly made, right? Like as you learn the language. But then I thought it would be nice to just have some exercises and generate some, make computers to generate some sentences. And I employed this Markov chain algorithm. So what it is essentially is, I will explain it from a point of learning the model and then how the action can be. So imagine we have a phrase, good morning, and so the Markov chain is essentially a state machine. It's a bunch of circles where you can be at any given point, and arrows where you can move from one circle to another circle. So if you take the good morning phrase, breaking down by words, you start from this end, the beginning, and the only way you can go is, it was a good word, and then the next one is morning, and then the terminator, the phrase this ends, right? And then you give it another phrase, good day. It starts exactly from the word good, then transitions to day, and then ends. And then give it another phrase, no good. Now, this would be the starting point. It goes to no, to the good, and then the good would be the terminator. And then the more you give it content, like the more sophisticated the state machine becomes. But what's special about the Markov chain algorithm, and again, it's applied only for like rubbish text generators, not in general, is that it builds a probability model such that the transition between the states is not deterministic. It's absolutely random, and the probability of this is defined by the frequency of the words. So if, say, we gave it this phrase 20 times, this one 10 times, and 5 times, summing up, we will come up with this. This accounts, not probability, but you can easily make it a probability. When now we want to use this model, the algorithm will pick randomly one of the starting points. Say we ended up here. This is the only way, the only transition possible here. So it will go here, no. Then the only way is go to here, good. And then we actually have 3 possibilities here. Very little probability to terminate the sentence, slightly more to go to the date state, and the more chances go to the morning, and so forth. So if we try to run it, we can actually generate a random phrase that looks no good day, going from here to here. And this wasn't in the initial input. And this way they make this IRC or Jabber bots. When they sit on the channel, listen to all the phrases, see like what combinations of words make sense more frequently, and then try to generate the rubbish out of it. And again, I don't have any example at hand. I would show you that I had this script, or you can play it on your laptop when you have the access. You have the script that takes the corpus of toki pona texts, sitting here, it's enormous, and it has, the grammar is not perfect that I showed you. But, so the way I decided to get away from the imperfections of the corpus was I take the sentence, I feed it to my parser, and I see if my parser can handle that. I mark it as a valid sentence, and then pass it to the Markov chain. If not, I just discard it. So the Markov chain is trained only on what I consider valid toki pona sentences. I have a bunch of models here stored, and then I have the Markov gen script that, based on these models, just generates the rubbish. And then I can pipeline it to the REPL that takes the sentence, invokes the parser, and prints out the parse tree. And I also have wrote last night a nice, convenient script that helps to translate it. It basically just looks up each single word and gives you the vocabulary entry. So it cannot translate it, but it gives you like the context, so you can get some idea of what is generated. And this is basically it. Thank you very much.